Recording has started, and I take you to the practice quiz. First two problems. State the distance formula and the midpoint formula from memory. Okay, 30 seconds more. All right, the distance formula. Like this. Now, these are actually the legs of a right triangle. If you squared both sides, you have d squared equals this squared plus this squared. And so remember, the distance formula is coming from Pythagorean theorem. The midpoint formula. The midpoint is you average the x coordinates, average the y coordinates. Subtraction in the distance formula, addition and dividing by 2, they kind of look at how they are similar and different. That is subtraction, that has an addition. That has a 2, but it's up in the exponent, making it bigger. That has a 2, and it's in the denominator, making it smaller. It's got some similarities and differences. That has a square root around it all. This is 2 separate points. All right, give me a little feedback on this, particularly on the 1, 2, or 3. If you'll recall our rubric for that, that's number 3. Number 1, you didn't really need the review. Number 3 adds insight, and number 2, it's helpful. Okay, go ahead and hit enter. Okay, and all right. Let's go one at a time through these. 2a, solve. X squared equals 9. Okay, 30 seconds more. Alright, I can just look at this one and tell that x has got to be 3. And am I done? At first I'd think yes, but close inspection, no. X equals -3 is also a solution. -3 times -3 is also 9. So you get 2 answers, and there's 2 ways we can go about the solution process. One way is we square root both sides. Trying to get rid of the square, the opposite of squaring is square rooting. But there's a rule. When you square root both sides, you must insert on one of the sides a plus or minus sign. So anytime you do an even root. Odd roots, you don't have to do that. So then that method would cause us to get both answers. The other way to do this problem is realize that it's what's called a quadratic equation. There's two primary ways to solve quadratic equations. And they both start with the same process, getting it equal to 0. And then we either factor this, if it factors, or we use a quadratic formula if it doesn't factor. This one will factor. X. Two things multiply to be negative 9 has to be 1 positive, 1 negative. 3 and 3. And then what will cause this one to be 0 is if x is equal to negative 3. What causes this one equal to 0 is if x equals positive 3. Because two things multiply to be 0, one of them has to be 0. And we can see what they are right here. So in either case, we get plus or minus 3. All right. Give me feedback on 2a. And go ahead and hit enter. And go to number 3. I don't know why. Alright, number 3. Find the square root of 16. Seconds more. All right. The big question, is this just 4 or is it 4 and negative 4? And because negative 4 times negative 4 also gives you 16. So isn't square root of 16 going to be both positive 4 and negative 4? The answer is no. It's only positive 4. And it's because square root, we've been saying it all along, wrong all along. It means the principal, or positive square root. If we were saying the full name of this sign, every time we said it, we get tired of saying that, so we shortcut it and just call it the square root. But what we really mean is the principal or the positive square root. And if this didn't mean this, then this radical sign would not be a function. Because you'd put square root of 16 into a calculator, you wouldn't get one output, you'd get two outputs, 4 and negative 4. So they decided they wanted this to be easy to use, wanted it to be a function, to have one output. So they define it so that this is the principal, the positive square root. Interested to know if this is clearing up anything for you, or if this was already stuff you already knew. So give me a little feedback on number 3. Go ahead and hit enter. Okay. square root of x is equal to 3. Solve that equation. Thirty seconds more. Okay, so this one, I can just look at it and tell, oh, x had to have been 9, because the square root of 9 is 3. I could have also done it by this process. I'm trying to get rid of the square root, so I do the inverse, which is squared. And if I do that to both sides, the square root and the square cancel each other out, and I get my answer, 9. Okay, now do the next one. Square root of x is negative 3. And let me move that true or false thing. Okay. So "30 seconds more. Okay, when I look at this, I might think a 9 at first. If I take the square root of x, oh, but that means principal square root, just the positive square root, so that wouldn't work. So then I'd say, all right, well, let's try negative 9. Then, now when I try to take the square root of negative 9, I can't do it, because it's what number times itself is negative 9. Positive number times itself is positive, and negative times itself is positive. So this doesn't work either. This has no solution. But there's something very important I need to point out here. If you did the solution process, and we square both sides, these would cancel out, square root in the square, and you'd get positive 9. And this is called an extraneous solution. It means the solution process tells you it's a solution, but it's not really the solution. There's no solution, so you have to throw it out. But it's something to be aware of when we're solving equations that have square roots in them, which is what we're going to get into today. We are going to get extraneous solutions at times. The solution process will tell us something's a solution, but it really is not. We have to throw it away. Extraneous solutions we always throw away, but the solution process will mislead us in these cases. Why does the solution process mislead us? It's because when we decided that this meant the principal square root, if we hadn't decided that that radical symbol meant the principal square root, we wouldn't have a problem over here, because there would be 2 square roots of 9, positive 3 and negative 3, and then this one would have been right. But since we said, we're going to make this into a function so that it only has one output, that's kind of an artificial thing that we're imposing on it, and the math of it doesn't recognize that, and it still thinks that 9 should be a legitimate solution. Alright, give me a little feedback on B and C. Where are y'all at with that? And go ahead and hit enter. Okay. True or false? So let's go through these one at a time. A. Put a T or an F next to that. 30 seconds more. Alright, this one is true. Square root and square kill each other off. You get x. Next one. Is that true or is that false? Okay, 10 more seconds. This one, if I take square root of x plus 3 squared, I'm really tempted to do this. But this is not correct. You cannot distribute the exponent to more than one term inside there. The correct way to expand it out would have been like this. And let me get a little more space here. We really needed to foil it like this. I like to put the like terms right underneath each other. So then we get x squared plus 6 squared x plus 9. We'd be missing that middle item if we had done it. And let me show you another way why this is false. If you take any two numbers, if you try to say that that's 1 squared plus 2 squared, this is 3 squared, that's 9. This is 1 plus 4, that's 5. These are not equal. But if you took 1 plus 2, 1 plus 2, and you FOILed them out, now we know the real answer is 9. If you FOILed it out, 1 plus 2 plus 2 plus 4, that's 3 plus 6, put in the first 2 and the second 2, and that's 9, and that does check. So you have to be FOILing it out to get the right answer. So this one, false. Common mistake when we get to these square root problems. Okay, and let's go 5a and 5b. We have to do those two. Seconds more. Okay, 5a, we've already seen this. You can do it by square rooting both sides. And when I square root both sides, I insert a plus or minus sign. And then I would get x equals plus or minus 5. We also saw it as if you get it equal to 0 and then factor, either way you're going to get 5 and negative 5. Or you can just look at it and say, 5 squared and negative 5 squared gives me 25. On B, this is a quadratic equation. Classic form for any quadratic equation. Let me show you the correct way to do it, but before I show you the correct way, let me show you a common student mistake. Common student mistake is this. Divide both sides by x. And then get x equals 4. It looks right, but you only have one of the two solutions. You lost a solution. So we don't divide by a variable. When you divide both sides by a variable, you will lose a solution. It's fine to divide both sides by a number, like 2 or 3 or something like this. But by a letter, we don't do that. And let me show you. If we did it the proper way, subtract 4x from both sides. This is a quadratic equation. Highest power is 2. Then we factor, or a quadratic formula. What's common to both terms is an x. We get this. And then what's going to cause this to be 0? What's going to cause this to be 0? We get our two solutions this way. Notice we miss the solution x equals 0 when we divided by x. That's the one you'll always miss if you divide by the variable. Because if you check it, put 0 in, it's going to 0 out both sides, but you eliminate that when you divide both sides by x. So we want quadratic equations where the highest power is 2 for the variable x. You just get them equal to 0, factor, or use the quadratic formula if it doesn't factor. Alright, give me feedback on these, 5a and b. And go ahead and hit enter. Alright, now let me get out of this and get back into it. Alright. So now do C. 30 seconds more. Okay, this is a quadratic equation. Add 2 to both sides. Then I factor it if it factors. Two signs must be both negative because I have to multiply to be a positive number, but still give me a negative middle term. 2 and 1, that will do it. And then x equals 2, x equals 1 causes each of those parentheses to become 0. And that's my solution. And if it hadn't have factored, you'd have used the quadratic formula, which I'll just throw up here to remind you. Use that formula if it doesn't factor. And give me a little feedback on C. Go ahead and hit enter. Okay. So now is time for questions. And last time we had class, we didn't have time for questions on previous homework. So you might have questions on more than one section here. And we can go back as far as you need to. So, anybody have a question to start us off? All right, if no questions, then let's go right into it. We're doing 2 sections today, 2.6 and 2.7. And their full titles are way up here. 2.6 is other types of equations, and the main thing we're going to be doing is equations that contain square roots in 2.6. And then 2.7, we'll get to that later. 2.6, the main topic, equations that contain square roots. And the first one is we're asked to solve this equation. All right. Now, if an equation contains a square root, we have steps. The first step is, well, what's the first thing that I would do over here? Would I square both sides to get rid of that square root? Well, not until I get that square root by itself. So I isolate the square root. Get it all by itself. Once you get it all by itself, so let's just go ahead and do that first step here. Alright, come over here and I'm going to add 1. And I'm going to divide by 2. Once I have isolated the square root, square both sides. Now, we have a big asterisk with this. Why do I put an asterisk? when you square both sides, this step can introduce extraneous solutions. Something that isn't really a solution, the solution process will tell you it is a solution. And we saw that in the practice quiz way up here. This one had no solution. But when we square both sides, it tells us that 9 is a solution. And this kind of thing happens quite often with equations that contain square roots. It's because of that definition of that radical sign being the principal square root, we wanted it to become a function. Right, so, because of this, checking your work is mandatory. You must check your work when you're dealing with equations that contain square roots, because quite often one of the answers doesn't work. We throw it out when it doesn't check. Alright, now we square both sides. We get y equals 9. We check. When you put 9 in here, you're going to get 3. Just do the left-hand side, and that turns out to be what it's supposed to, and it checks. Alright, so let me have you do problem number 2. I'll give you a minute with number 2. Alright, so the first step is isolate the square root, and that's already been done. The square root is alone on one side. So we go and we are going to do the second step, which is square both sides. And what I'm going to get is the square root and the square cancel out. And I get this. But this is a quadratic equation. And the solution method for solving quadratic equations is get everything to one side and get the other side equal to 0. I like my x squared to be positive for factoring, so I'm going to move everything to the right. And then we factor. And if it doesn't factor quickly, jump to the quadratic formula. X times x give me x squared. Now, two things have to multiply to be negative. The only way that can happen is if one's positive and one's negative. So we look at the sign of the last term first, and it helps us determine our signs. Now we need two things that multiply to be together to be 20. But when I subtract them, I get 8. And that's going to be 10 and 2. And I want the larger one positive. Like this. So then, x will equal negative 10. X, because that will cause this to be 0. X is equal to positive 2. That will cause this to be 0. Now, negative 10, if you check it right here, watch, it's negative 10 squared minus 80 minus 20. That's 100 minus 80 minus 20. Negative 10 checks here. But that doesn't mean that it checks here. 2 is going to check here as well. 2 squared plus 16 minus 20. That does turn into 0. That checks here, but that doesn't mean that it checks up here. We've got to check them all the way up here. So let's check. X equals negative 10. So I'm going to get square root of 20 minus 8 times negative 10. Square root of 20 plus 80, which is square root of 100, which is equal to 10. So when I plug in negative 10, for the left-hand side I'll get 10. For the right-hand side I get x, which is negative 10. But they do not equal each other. Doesn't check. So, what do I do with the 10, the negative 10? I throw out that answer. It had to check. Now, I'm going to check 2. So I come back, square root of 20 minus 8 times 2. Make sure, yeah, 20 minus 8 times 2. And this gives me square root of 20 minus 16, square root of 4, which is 2, and the right hand side, when I plug in 2 for x, I get 2. This one does check. So my solution is just x equals 2. That's it. Throw away the other. That one is called an extraneous. For x equals negative 2. For x equals negative 10. Any questions? Okay, so equations containing square roots. Isolate the square root. square both sides. But we've got to check at the end. All right, we have time for one more problem before we take a break. Let me give you, now, I want you to go into your group and state what the first step would be on number 3. What's the very first step? And we see how many groups we have in this class. We got 6 groups. Let's just have a real quick check-in with the group numbers. So go into your group and just type in hi, so the group can see that you're here. And group leader, make sure you group knows who the spokesman for the day is. And group 1, how many of you are here today? Nobody here from group 1? Group 2, how many are here?
Mr. Shankin, there's 2 of us.
In what group?
Group 1.
In group 1, oh, there's just 2 of you. All right, in group 2, how many of you here?
We have 3. Oh, we have 4.
4. Group 3, how many?
Only 1.
1. Group 4?
3.
3. Group 5?
Looks like just 2.
2. And group 6?
3.
3. All right. Group 3, I want you to join group 1. So there's one person there. Go into group 1, unmute the channel for group 1, and type in hi so they know who you are. And let me have group 5 join group 6. So you guys do the same thing. All right. And group 4, what's the very first step in solving this problem? And you can always pass group 4. But what's the very first step?
Pass.
Pass? Okay. Let me go to group 6. What's the very first step for to solve this one?
To subtract 7 from both sides to isolate the square root.
Ah, that's what we're going to do. Subtract 7 from both sides. Now, if we tried to square both sides instead of doing that, oops. This is a very common student mistake. Squaring both sides here. And then they do something like this. And the problem with doing that is this can't go into both. This is wrong. This is making the mistake on one of these practice quizzes. It's this one. is distributing the exponent to the two parts when there's more than one term inside the parenthesis. And it's really easy to do. It feels like natural. Wow, for sure, let's do this. But no, you get the wrong answer when you do that. And so that's why all this is the wrong way to go about it. But if we do this, and we isolate the square root, then we're on our way. All right, so we're past our break time. We'll finish this up after a break. So we're going to start again. Uh, 132. And we'll finish up this problem. And if you want to, you can be working on that, or you can just take a break. Does anybody have anything they want to talk to me about before I take my break? Okay, I'm going to mute and take my break. Okay, we shall start up again, and so we need to work this out. And we've done the first part. Step 1 was isolate the square root. We've got to isolate it. Square root's alone on the left-hand side. Step 2, square both sides. So we do this. Square root and the square kill each other off. And this has to be multiplied out by foiling it. You got to get that middle term. If you just distribute the x squared minus plus 49 or something like this, it's not going to give you correct solutions. So we're going to have to take x minus 1 on the left. On the right, we multiply this here and here, x squared minus 7x minus another 7x plus 49. So we're going to get x squared minus 14x plus 49 equals x minus 1. Now this is a quadratic formula. So quadratics, we get equal to 0. So we move these numbers over to the right. Okay. Now, if the size of these numbers is intimidating you and that you don't want to factor it, then that's fine. We can just use the quadratic formula. If you feel like, oh, let me try to factor it, let's see what happens. And if you do, either way is fine. The two signs have to be negative because they have to both multiply to be a positive. And then we want a negative middle term. Two numbers that multiply to be 50 but add to be 15 are 10 and 5. And then when you said 0 is this number times this number, when you think of what's in parentheses as one whole thing, then this has to be 0 or that has to be 0, so x is equal to 10 or x is equal to 5, positive 5. We're done, except when we squared both sides, that could have introduced extraneous solutions. So we have to go back to this, and let me copy that in again down here. And so I'm going to check. And if I plug that in, I'm going to get square root of 9 plus 7. Does that equal 10? And it sure does. Check. If I plug this one in for the check, plug in 5, I'm going to get square root of 4 plus 7. Does that equal 5? And the answer is only if the square root could also mean negative 2. But remember, we kind of have artificially stated that that's a principal square root, turning it into a function. So this doesn't work. No. So this solution we toss out. The only solution that's valid is 10. All right. Now, we've got one more of these problems. With this last one, well, you know what? Let's come back to this number 4 as time permits. Because I want to make sure that we get through the basics of this other stuff. That's more important than this special case problem. All right. Let's go to 2.7, linear inequalities. And bread costs $3 per loaf. You go to the bakery. X is the number of loaves that you purchased. Write an equation which includes X for spending exactly $24 on bread. So, let me have you do number 1A and work on that individually. Okay, go to your group chat, type in what you got in the group chat, see what others have got, and discuss it if you need to. Alright, group 1, what do you have for A? I heard somebody kind of turn on their mic, but group 1, you got anything for A? You can always say pass. Okay, let's go to group 2.
Would it be y equals 8x?
Write an equation. Alright, so you're saying y equals 8x. Okay, now, I only asked for one variable, x, and you put 2 of them in. That's kind of neat. Can you do it also without the y? What if we took the y out? What would you replace it with? Anybody? What would go on the other side? I think it's the 24. You got to expend exactly $24 on bread. It costs $3 per loaf. So you multiply the number of loaves. Oh, where does 8 come from? And here, I think you're solving it for 8. I think we could also get, let me just get one more group's opinion on this. Group 4, what do you have? Anybody from group 4? You can say pass. Let's go to group 6. What do you have?
3x equals 24.
3x equals 24. I think this one will match up $3 per loaf times the number of loaves and we got to get exactly 24. All right, so let's do that. And now, the 8 is going to come about as the solution of this. Because you divide by 3, you're going to get 8, and I think that's where that 8 was coming from before. All right, now let's go to, you can spend at most $24. How does this change your equation? So let me give you a minute. Okay, enter your answer in your group channel. All right, let me go to group 5, since you're on a roll. How does that change the equation?
We have 3x is less than or equal to 24.
That would be it. So, the situation of when do inequalities ever come about? When do equations come about? When you had something that had to be exactly true. When you have words like at most or less than or greater than or something, you must spend greater than $24. Then we had a greater than sign. This is how inequalities come about. And equations have a single solution. This would have multiple solutions. All right. So now let's go to solving equations versus solving inequalities. We solve inequalities just like we would solve an equation. So I would do exactly the same way I would solve an equation. Divide by 3. X is less than or equal to 8. Now, we know that there are 3 ways to display this answer. You can do it like as an inequality, as an on a number line, everything to the left of 8. Or you could display your answer as interval notation. 3 ways to state your answer. All right. Now, we solve it exactly the same way we would solve an equation, except there's one giant exception to this rule. And the exception to the rule, we need to understand it. So I want to come over here. 5 is greater than 3. That's a true statement. I'm going to multiply both sides by 2. And do I still get a true statement? Well, yeah, 10 is greater than 6. I'm going to subtract 1 from both sides. Do I still get a true statement? Yes. I'm going to add 100 to both sides. do I still get a true statement? Whatever I do, as long as I do it to both sides, divide by 10. As long as I do the same thing to both sides, just moves the decimal point, and it's still true. Alright, there's something I can do though, that I'm going to do to both sides, that's going to make this a false statement. So, think about that for a moment. What can I do to both sides so that it's no longer true? And enter that into your group chat. What you're doing to both sides to make this equation no longer true. Talk it out for a moment in your group chat. And okay, I'm going to open the floor up to anybody. What could I do that I do to both sides, then this is going to be no longer true?
This is group 1.
Yes?
We think that if you divide both sides by a negative number without putting the inequality sign,
So let's do that. Divide. Let's make it the simplest number I can think of by negative 1. So then, negative 5 and negative 3. Now, who has more money? The person who only owes $3 or the person who owes $5? It's now false. This is saying the person who owes $5 has greater wealth than the person who owes $3, and it is false. And it's not only dividing, you could also multiply if it's by a negative number. Multiply by, let's say, negative 2. So 5 and 3, that would be negative 10 and negative 6. And if you kept the sign the same, it would still be false. Okay. And let's take a visual of this. Why is this the case? Let's look at a number line. Okay, think of 3 is this arrow. Think of 5 as this arrow. Now, what it means to be 5 is greater than 3, the formal definition is 5 is greater than 3 because it's to the right of 3 on the number line. That's the real definition to be larger than something else, is to be to the right of it on the number line. Now, negative 3 is over here. Negative 5 is over here. When you multiply or divide, let's say, by negative 1, what you've done is turn this arrow in the other direction. And you turn this arrow in the other direction. And you have the one that was further to the right is now further to the left. And it's the same kind of situation as what we think of as negative sign. Multiplying or dividing by negative 1 is kind of reversing somebody's fortune. So, suppose you just got married and you borrowed, this is way back in, before there was money, and You just got married and you borrowed 3 sheep because you were going to start your own family and you get your own herd. You're going to be a shepherd. And your brother just borrowed 5 sheep. And brother's like, I'm gonna get my herd up much quicker than you. But then disaster happens. All the animals got sick and they all died. And now he was better off, but now he's worse off when you reverse your fortune. You're, compared to your brother, in better shape. You only owe 3 sheep. While your brother's way over here, the reversal of fortune. Alright, so what we say is that when you multiply or divide both sides of an inequality by a negative number, then you must reverse the inequality. At the time that you multiply both sides by a negative number, you reverse the inequality. So it looks kind of like this, that if I had 5 greater than 3, then let's say I'm going to multiply both sides by -2. Since I'm multiplying both sides by a negative number, I cross this out so that the next time I write it, I put it in the correct direction. It's pointing to the right, now I point it to the left, and then I'd be correct. So that's the procedure we're going to use when we implement this. Alright, so go ahead and do C. Let me give you a minute to do C. Alright, so I'm going to subtract 3 from both sides, just isolate my x. I'm going to divide both sides by -2. But when I divide by a negative, that sign's going to be wrong. So the next time I write it, I turn the direction, and I have this. That's my solution. Now, let me show you a whole nother way I could have done this problem. Notice there are 3 terms, 2 on the left side of the inequality and 1 on the right. Suppose I move all the x's over to the right, and I move all the numbers to the left. I get -6 greater than, these cancel out, 2x. I divide by 2. Now this time I'm dividing by a positive number, so I don't change the inequality. I get -3 is greater than x. But if somebody tells you -3 is greater than x, if somebody tells me that, I don't know what they mean. My mind can't process it. But if they tell me verbally in the other direction, x, keep the arrow pointed at the x is greater than -3, then I know what they're talking about is wherever -3 is, that it's everything to the right of that. I can immediately visualize that. I can't visualize when it's said backwards. So we always state our final answer with the x first, And notice I get exactly the same answer. Either way I did it. And if you used the rule that you could never divide by negatives, you would always have to move your negative x terms to the other side. And when you move to the other side of an inequality, it's equivalent to changing the direction of the inequality symbol. Now, the same could be said of equations. That you could say, all right, if that was an equals 9 instead of greater than 9, and if we had to add 2x to both sides and move the x to the right so that we divide by a positive 2 instead of a negative 2. The thing is, with equal signs, it doesn't matter when you move to the other side. It doesn't change the value of the equation. But on inequalities, it does change things when you move the variable to the other side of the equation. All right. So now we could also state our solution in interval notation, which is negative infinity to negative 3. So all these different ways we could state our answer. Is an inequality, interval notation, or on a number line. Any questions? Okay, let's move to the next. All right, graph the following.
Mr. Shankin,
Yes.
this is Beverly. Didn't you, I think you flip-flopped the answer on the last problem. You said that x was greater than negative 3 even though it's written out as negative 3 is greater than x.
Correct. When that said this right portion, it said negative 3 greater than x, but we wouldn't leave our answer that way. You always have to lead off with x. So I have to...
Wouldn't x be x then be everything to the left of negative 3, not to the right?
Oh, you are correct. Thank you, thank you. So my graph is wrong. Thanks for pointing it out, Beverly. All right. X is less than negative 3. I did it right over here, but I didn't do it right over here. Okay. Thank you for catching that. All right. So now let's graph the following. It says that x. Now, how you read this? A lot of people read this from left to right. 3 less than x less than or equal to 5. But it's more easily understood if you read it from the middle every time. X is greater than 3 and x is less than or equal to 5. So this is what it really means is x is greater than 3 and notice the key word is and. X is less than or equal to 5. And if you interpret it that way, it's easy to draw the picture of this. Here's 0, here's 3, here's 5. And when I graph this, I put an open circle at 3, a filled in circle at 5, and it's everything in between. Alright, so next I want you to graph this one. So take a minute and graph the second one. All right. This one should have made you, it makes me a little bit crazy. It's really hard to figure it out. In fact, whenever you have, this is called a double inequality. It means x is trapped between 3 and 5. Can't equal 3, but it can equal 5. This is bad notation. We never leave a final answer like this. Sometimes we get something like this along the way, but we always turn it around before we report it to somebody. We turn it around, and now when you turn these things around, it'll come like this. Come like this. The 1 will go over here. Notice the arrow's pointing at the 1, and the arrow's pointing away from the 2 and at the x. This means the same as that. When you reverse them around, once you have it in this format, I can tell what it is now. This is between 1 and 2, fill in the 1 and not the 2. So, don't ever leave your answer in this format. With double inequalities, all the arrows are supposed to be pointed to the left. This is what we call bad form. It's just hard to understand what it means. So we always turn it the other way. Alright. Make a graph for the next one. 3 is less than x greater than 4. Give you just a quick little bit of time here. And hopefully you're getting really frustrated with this because this is even worse form. We don't allow this form, even temporarily. So 0, 3, 4. This is saying x is bigger than 3 and x is also bigger than 4. This is illegal. We don't allow this. The only time we allow double inequalities is when they're both pointing in the same direction. And in final format, for an answer, they have to be pointing to the left. And if you have something like this, it's really trying to say something x is greater than 3 and x is greater than 4, and what's this all about? We can't tell. Okay. So this last one here, make a graph. Draw what that means on a number line. Okay, this one. This should also drive you nuts as well. It does not mean x trapped between 1 and 3. This means if we write these, inequalities are best understood singly with the x coming first. X is less than or equal to 1. When you put them together as a double, you're implying the word and. X is greater than 3. Now, how can a number be to the left of 1 over here and at the same time to be to the right of 3? It can't be. This is also illegal. The arrows have to point to the left on a double inequality in final form, and the smaller number has to be to the left, bigger number to the right. Any questions? Any of this? All right, let's go to when we solve a double inequality, this is the proper format. Both arrows are pointing to the left. We can solve these by working simultaneously on all three sides. There's a left, a middle, and to the right. And we can go like this. So this can go nice and quickly. -6 and 16. And then I divide by 3. Dividing by a positive, so no signs get flipped. And then I get x is greater than or equal to -2, less than or equal to, I might want to change this into 5 1/3. Oops, this equal sign. It's not supposed to be here. Okay, so that's it, and in interval notation it would look like this. Alright, let's talk about and versus or. So, this one is kind of English, and so I have a shirt on and I have a hat on. How is that different than I have a shirt on or I have a hat on? So, go into your group chat. See if you can explain the difference. I'll call on a group in a moment. What's the difference between these two? Okay, group 5. What's the difference? No, group 6. What's the difference between these two? Anybody from group 6?
Yes. The difference is that if you have a hat and a shirt on, you're wearing both at the same time, and if you have a hat or a shirt on, you are only wearing one at a time.
Both must be true. You're wearing both a shirt and a hat, and only one. Must be true. Now it could be the case that both are true down here. But only one of them has to be true. Only one of them must be true. And, alright, we use this in situations like, suppose height h is height in feet. Did you know that in order to get into the military, that there are height restrictions? Now I made this up. I don't know if this is, this is not what the actual height restrictions are. But it might be the case that you can be a member of the military only if your height is greater than 5 feet, greater than or equal to 5 feet, and less than or equal to 6.5 feet. Now, why in the world would the military restrict and don't want really short people and really tall people? Well, it turns out it's for efficiency reasons. They don't want to have to build tanks that can accommodate somebody that's 7 feet tall, or that accommodates somebody who's 4 feet tall. They just say, we're going to build a standard sized tank, and if people are limited within these certain ranges, they can still reach all the instruments that they need to, and so on. And same thing with bunk beds. They just say, all right, we're gonna, if you're taller than 6'5", it's just cheaper for them to not let them in the military rather than making all the beds, really long to accommodate the few 7-footers that can come there, and so on. So you can be a member of the military. Notice the keyword "and." Suppose they'd made a mistake and they'd put the word "or" in there. Then, now everybody is either larger than 5 foot or smaller than 6'5", because if you look at the graph of it, here's 5, 6, 7, greater than 5 feet, greater than or equal to 5 feet, like even somebody who's 8 foot tall is greater than or equal to 5 feet. Less than or equal to 7 feet, or 6.5 feet, is over here. And even somebody 3 feet tall is less than or equal to 6.5 feet. So if they'd used the word "or," one of these would have been the case, and they'd have made a serious mistake if they'd have used the word "or." What they mean when they say "and" is they only are going to allow the overlap between these two sets. So see how they overlap here, where you're both green and red, and that's the only thing that's allowed to be a member of the military if this and this. When you have "and," it's called the intersection. Of these two lines, where both lines meet. Now, suppose you have a specialty sizes store. And the specialty size store is for you if your height is less than or equal to 5 feet or greater than or equal to 6.5 feet. All right, now this needed the word "or." If they'd have put the wrong word and put "and" in here, nobody meets that condition. Nobody is to the left of 5 and to the right of 6.5 simultaneously. You can't be both super short and super tall at the same time. This precise use of the word "and" or "or" is really important. If you screwed up legally, like if the military had accidentally used "or" in here, a lawyer could say, all right, you have to let this 7-footer in, and so on. All right, so we can see what the graphs of both of those. So on this second one, the "or" case is 5, 6, 7. What that looks like is over here and over here. This we call the union. It's not where the two intersect. They don't intersect at all. We just do all of this and all of that put together. All right. And so that takes you through everything we needed to your homework. It's 2.6 and 2.7. There's this one specialty problem that we never got to in the 2.6 to solve that tough case. And I think there's one, maybe even two, that are like that in the homework. And you can give that a try. And certainly that's probably something you want to ask a question about next time. And I will see you all after the weekend. Have a good weekend. Does anybody have any questions? Does anybody need to speak to me for anything?
Hi, Mr. Shankin. This is Vanessa.
Hi, Vanessa.
So you had said that if we turned in the whole homework on the spot checks, that we didn't have to turn it in for the actual, for like the
Correct.
inbox homework. Okay, but the thing is, I didn't do the worksheet last time, so is it okay if I just submit the worksheet?
So, are you talking about the radicals worksheet?
No, the extra, I think it's 3 homework. It's just the one worksheet that, it was assigned with, 1.3.
The 1.3 extra worksheet? Okay. So what you're asking then is, so you missed turning it in for the spot check. Is that right?
Yes.
Okay, but did you get the other part in for the spot check, the 1.3?
Yeah, I turned in the whole homework for 1.3 and for 1.2, but I missed the worksheet. So can I just turn in the worksheet for the homework assignment, or do I have to reset?
That's fine. That's fine. For the homework assignment, you can. Now, sometimes that confuses me when I see just part in one and part in the other. And if I accidentally mark you off for that, you'll have to just remind me. But yes, in theory, you should be able to submit that there if I don't get confused when I'm grading it. And I probably won't, especially now that you told me. I'll look for that. And so you don't have to do the whole thing. And I'll give you credit for the spot check for 1.3 as well, even if you didn't have that worksheet.
Okay, thank you. I just wanted to make sure.
Okay, you're welcome. Anything else? Okay, let me stop the recording.